Today is December 4th. And just like yesterday, we're doing more of the same thing we did on Monday, which is basically a lot of factoring. And so the rule again is factor first. Factor, factor, factor. We want to be able to factor and then simplify by reducing. But today we're dividing rational expressions. It's the exact same thing we did yesterday, except how do you divide fractions? Multiply by the reciprocal. Yes. Keep, change, flip. Change the sign, flip the fraction. We do not divide, ladies and gentlemen. We keep, change, flip, multiply by the reciprocal. We change it into exactly what we did yesterday. Our division changes to multiplication, and we flip the second fraction. So that's going to become 14 over 15. So all we're doing new today is converting into a product. All right, keep, change, flip. And then we are factoring, just like we did yesterday. 10 can factor into what times what? What are the factors of 10? 5 times 2. Thank you. Woo, baby. 21 is what times what? 7 times 3. 14 is 7 times 2. And 15 is 5 times 3. Once you factor, it's easier to see how things reduce. So we have a giant product, and we can reduce the common factors. 5 divided by 5 is 1. 5 goes into 5 one time. What else reduces? 7. 7 goes into 7 one time. And we have 2 times 2 is 4. And then 3 times 3 is 9 in the denominator. So same exact thing we did yesterday. It's just that the first thing we need to do is keep, change, flip. Nothing different going on today. More factoring. All right. So here we go. Here we go. Example 1, express the quotient in simplest form. Express the quotient in simplest form. Express the quotient in simplest form. So we have 5x over 3x minus 12 divided by x squared minus 2x over x squared minus 6x plus 8. You can come back to me if everybody says no, okay? Okay, thank you. Thanks. Okay, how do you divide fractions? Keep, change, flip. Yeah, keep, change, flip. So we're going to change the sign, and we're going to flip the second fraction. And I'm going to do that all in one step with my factoring so I can save myself some time and energy and effort and work and all that jazz. 5x stays in the numerator. Can I do anything with 5x? Not really, no. I can write it as 5 times x. I mean, that's what it really is. So maybe it's helpful to separate those things to realize that they're a product. What about the 3x minus 12? What can we do with 3x minus 12? Take out a 3, greatest common factor. Take out a 3. If we take out a 3, what's left behind? X minus 4, good. When we're taking out a 3, we're really just dividing each term by 3. I don't want to divide fractions. What do we do instead? Multiply. So we change the sign to a giant product, and we're flipping this fraction. So the numerator actually comes from this denominator. X squared minus 6x plus 8. What can we do with x squared minus 6x plus 8? Double bubble. It does double bubble. What times what is x squared? X times x. And what times what is positive 8? Negative 4 and negative 2 would be a good choice there. Negative 4 and negative 2. Check the rainbow. And then we have this x squared minus 2x. That's going to flip into the denominator. What can we do with that x squared minus 2x? GCF. Yes, there's a GCF. We can take out an x. What's left over if we take out the x? X minus 2. Again, we're just undistributing. So now everything is done, and now we can reduce. What can we reduce here? What? X minus 2. Oh, I think I heard x. X minus 2 goes into x minus 2 one time. What else reduces? X minus 4 goes into x minus 4 one time. What else reduces? The x on the bottom and the x on the top. X goes into x one time. And so we are left with a 5 times 1 times 1, which is just 5 in the numerator, and a 3 times all those ones, which is just 3. That really cleaned up to 5/3. Crazy. All right, letter B, 6x squared plus 7x minus 3 over 6x squared divided by 2x squared plus 3x. So I want to see fraction divided by a fraction. Is 2x squared plus 3x a fraction? No or yes? How do I make it a fraction? Yeah, there's a 1 underneath it. So always, anything can be turned into a fraction just by putting a 1 underneath. Now it's a fraction. And again, we are not dividing. We keep and we change the sign and we flip the fraction. So we will do that all in nice one fell swoop. So let's look at the 6x squared plus 7x minus 3. What can we do with that? Double bubble. Yes, it does double bubble. What times what is 6x squared? 3x times 2x. Good. And then last times last has to be negative 3. What times what is negative 3? Negative 1 and positive 3. Negative 1 and positive 3. How do you know if you did it right? Check the rainbow. Definitely check the rainbow. Anytime you have a number in front, you must check the rainbow. 3x times 3 is 9x. Negative 1 times 2x is negative 2x. And when we combine those, that's where our 7x comes from. So we know we did it right. What can I do with the 6x squared? Not much. But I could say it's 6 times x if I wanted to. X squared means x times x. So you could write it out. Sometimes that's helpful. I'm going to change my sign to a product. And remember to flip my fraction. So what's my numerator now? 1. And then what can I do with this 2x squared plus 3x? GCF. Very good. So we're going to take out the x, and what's left behind? 2x plus 3. Good. It looks like 2x plus 3 goes into itself one time. Does anything else cancel? Do these x's cancel? No. They have to be top and bottom. One on top, one on bottom. Those will cancel. But those are both all on the bottom, so they don't cancel out. We have a 3x minus 1 in the numerator. What's in our denominator? 6x to the third, 6x cubed. Very good. Any questions on either of those? Same old stuff, right? Isn't this great? It's just factoring. Factoring. Lots of factoring. All right, last one. Bienvenidos. 3x squared minus 5x over x minus 5. Divided by 9x squared minus 25 over 5 minus x. Ooh, interesting. What's interesting? Why is what? Hi, yeah. This one here?
No, I mean the 3 and 9 and then 5 and 25. So this is
Oh. That's not what I was looking for, but that's interesting. These are kind of the same. Yeah, they're not quite the same though. What's wrong with 5 minus x? Is it in the right order? No, it's not in the right order. And for now, what I want to do is rearrange that order because it seems a little bit weird to me. So this is a negative x, and this is a positive 5. So I'm going to rewrite that in the proper order because that's going to make my life a little bit easier for us as we go. I do not divide fractions. I keep change and flip them. So I'm changing the sign, and I'm going to flip the second fraction, and I'll do that as we go. What can I do with this numerator? 3x squared minus 5x. Take out the x. So there's a greatest common factor of x there, which leaves behind 3x minus 5. Can I do anything with the x minus 5? No, it's a bubble. It's a prime factor. It doesn't have anything other than 1. I could take out a 1 if I wanted to. I'm going to change my sign to a product, and I'm going to flip my fraction. What can I do with this negative x plus 5? It has a GCF. What can I take out of it? A negative 1, yes. Anytime I have a leading negative, I want to take that negative 1 out in front. If I take out the negative 1, what's left behind? X minus 5. You can always check by distributing. Negative 1 times x is negative x, and negative 1 times negative 5 gives me that positive 5 I'm looking for. So anytime you have things that are out of order, you can take out the negative 1 and change the order. Kind of nice. What can I do with the 9x squared minus 25? Double bubble. It does double bubble. And it turns into my denominator. Remember, flip the fraction. What times what is 9x squared? 3x times 3x. And what times what is negative 25? Positive 5 and negative 5. Good. So we can reduce some stuff here. 3x minus 5 goes into 3x minus 5 one time. X minus 5 and x minus 5 goes into itself one time. What am I left with in my numerator? Negative 1x, or negative x, And in my denominator, 3x plus 5. All right, do you guys have any questions for me? Okay. Then we are working on CP79.